Okay, today's video is going to be a review of factoring. We are starting section 5.3, which we're going to spend 2 days on. Section 5.3 is solving quadratic equations by factoring. So in this video, we're just going to review factoring, and then in tomorrow night's video, we're actually going to start solving by factoring. So before we jump into the factoring, I want to review what it means to be a quadratic. A quadratic is an equation or expression where the highest term, so the highest power, is x squared. So we're going to be looking at expressions or equations that have a highest power of x squared. So this should all be reviewed. You factored last year, you factored in algebra, so you have seen this before. There are 3 main methods that you should know for factoring already, and they're over here to the left. There's GCF, so the greatest common factor, product sum, and then the difference of squares. You should always start out with the greatest common factor. So you're going to look at all your terms and see, is there anything in common that I can take out? So in this first example, if I'm looking at both terms, just at the numbers, the 6 and the 9, I can take out a 3. So they're both divisible by 3. The first term has x cubed and the second term has an x. So the lowest number is what I can take out. So I can take out an x. And then I have y and y to the 4th. Again, I can take out the lowest power. So 3xy is what they both have in common that I'm going to take out. If I have a 6 and I divide out a 3, I'm going to be left with 2. If I have x cubed and I divide out an x, I still have 2 more x's left. I had a y, but I divided a y out. Now going on to the next term. I have a 9, I can divide out a 3, so I'm left with 3 again. I had one x, but I took it out, so there's no more x's left. I have y to the 4th, but I took out a y, which leaves me 3 y's. So this is our final answer. So hopefully this should look familiar. So any factoring problem, you're always going to look at your however many terms you have and ask yourself, is there anything in common? So right now, I want you to pause the video and try this example to the right. See, is there anything in common between the 2 terms? Okay, so let's see how we did. First thing, if we consider the numbers, the 12 and the 2, the highest number I can divide out of both is a 2. First term has an m, but the second one does not, so I can't factor out an m. I have an n squared and an n. I can always take out the lowest one, which would leave me with an n. So now I need to see what's left. If I have a 12, but I divide out a 2, I get a 6. I have an m still, because I didn't take that out. I had n squared, but I took out one n, so I have one n left. Now this is where a lot of students make a mistake. A lot of students just stop there and say that that's the answer. But if I have a 2n and I divide a 2n out, I'm left with a 1 still. So that 1 is really important. You can't forget the 1. Now, you should be checking your answers. The way you can check this is by multiplying back out. So if I multiply that 2n back in, I'm going to get 12 mn squared plus 2n, which is exactly what I started with. So that's always a good mental check. When you factor, you should be able to multiply back out what you ended up with, and you should be back to where you started. So that's the first type of factoring that you've seen. The second type of factoring is called a product sum factoring. This factoring is always going to have 3 terms. You're going to have an x squared term, an x, and then just a constant term. Okay, so product sum is called product sum because you are looking for the 2 numbers whose product is going to give you the last number, product meaning multiply, and whose sum is going to give you the middle number. So if I think, what 2 numbers multiply to 15 and add to negative 16? Okay, if I think about numbers multiplying to 15, I get 1 and 15, 3 and 5. That's kind of it. I also consider the negatives, so negative 1 and negative 15, or negative 3 and negative 5. Now I need the numbers whose sum is negative 16, so that'll be negative 1 and negative 15. So my final answer then becomes x minus 1, x minus 15. Now, order doesn't matter, so I can put the x minus 15 first and then the x minus 1. So that's product sum. If we look at the next example, again, we are looking for two numbers whose product is negative 72, so that multiplies to negative 72, and whose sum, in this case, is a 1. So pause the video right now, come up with the two numbers that multiply to negative 72, but add to 1. Okay, so let's see how we did. You should have come up with x plus 9, x minus 8. So 9 and negative 8 are going to multiply to negative 72, but add to be 1. Okay, so let's move on to difference of squares. So difference of squares you've also seen before. Difference of squares is called difference of squares because difference means subtraction. Squares refers to perfect squares. So perfect squares would be like 1, 4, 25, 9, 16. So in this case, 4 is 2 times 2. 25 is 5 times 5. Okay, so to get the 4, I'm going to need a 2 multiplied by a 2. To get the 25, I'm going to need a 5 multiplied by a 5. To get x squared, I'm going to need x multiplied by an x. Now, if it's a negative 25, I need 1 positive 5 and 1 negative 5. So that's the difference of squares. This one's a little tricky. You have to be able to recognize it right off the bat. You're going to know something is a difference of squares if all of your terms are perfect squares. So if we look at the stop sign problem, 25 is a perfect square. It's 5 times 5. 16 is a perfect square. It's 4 times 4. So I'm going to start you out. So 25 is 5 times 5. 16 is 4 times 4. Then you need to ask yourself, how do I get x to the 4th? How do I get y squared? So pause the video right now and finish this problem. Okay, let's see how we did. To get the y squared, you would need to multiply y and y. To get the x to the 4th, you would need x squared and x squared. And now because it's a negative 16, you need 1 positive 4 and 1 negative 4. Now again, the order doesn't matter. I can definitely switch the two of these binomials, and that's still the correct answer. Okay, so this all should have been review. Again, you did some of it in geometry and some of it in Algebra 1. If this is not a review, though, and you're really struggling, if you see up here at the top, there is another factoring review that's on Schoology. So it's another video. It's going to go through these same 3 methods. It's going to go through greatest common factor and product sum and the difference of squares some more with some more examples. If you need more examples, please review that video on Schoology. If you're ready to move on, we're going to move on to one more product sum. So this is something that you have seen before, but it's a little bit trickier. So if we look at this next one, this one is different because we have a leading coefficient. This is called a leading coefficient. A number out in front that's not 1. So it looks kind of like method 2 up above with product sum because we have those 3 terms. But the number in front is not a 1. So that changes things. You're still going to look for a product and a sum. The middle number is still your sum. The product, though, is where things change. So what you're going to do is you're going to multiply the first number and the last number. So in this case, I get negative 12. That is the product that I'm looking for. So I'm looking for two numbers that multiply to negative 12, but add to be negative 11. That's going to be negative 12 and positive 1. So negative 12 and positive 1 add to negative 11 and multiply to negative 12. Now, that's where the product sum part of this comes from. Next, we have the split the middle. So what you do with these two numbers now, you're not done. What a lot of people do is they go, okay, x plus 1, x minus 12. No, that's not the case. You're going to be splitting this middle term up. So instead of writing negative 11x, you're going to be writing negative 12x plus 1x. So negative 12 plus 1 does give us negative 11. Then our first term and our last term stay the same. Now that we have 4 terms, what we're going to do is we're going to factor the left side and we're going to factor the right side using GCF. So on the left side, out of my 2 terms, I can take out a 3. I have an x squared and an x, so I can factor out an x. Now, if I have a 3x squared and I take out a 3x, I'm left with another x. 12x and I factor out a 3x, I'm left with a 4. On the right side, I can't factor anything out except a 1. Now, if I'm doing this correctly, my parentheses should be the same. That's my first term. The numbers out in front are my second term. So hopefully this rings a bell. What I want you to do right now is I want you to pause the video, and I would like you to do this stop sign problem to the right. You're going to start it the exact same way. So figure out first, what product am I looking for? Once you find those 2 numbers, you're going to use them to split the middle. Pause the video and try that one on your own, please. Okay, let's see how we did. This negative 23 is the sum that you are looking for. You have to multiply the first number and the last number. We get 120, and that is our product. So I'm looking for 2 numbers that multiply to 120, but add to 23. Now, I would bet most of us can't figure those out right off the bat. So we're going to have to start writing down numbers that multiply to 120. We get 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20, 7 doesn't go in, 8 and 15. Now, hopefully we recognize at this point that 8 and 15 is what we want. In this case, we want negative 8 and negative 15. So what we're going to do, it's called split the middle. We are rewriting the middle term. Instead of negative 23, it's going to be negative 8y minus 23y. So we need to ask ourselves, is it true that negative 8y, this should be a 15. Sorry, my mistake. Now, how did I know that I made a mistake? Well, I need to make sure that these 2 give me negative 23. And they do. What I had written before didn't. Now, last term stays the same. First term stays the same. At this point, I'm going to write a line down the middle, and I'm going to factor the left side and the right side. On the left side, I'm going to factor out a 2y. I'm left with 3y minus 4. Out of the right side, between 15 and 20, I can take out a 5. And I'm left with negative 3y plus 4. Now, I said before, those parentheses should match. Ours don't. That's an issue. So we have the same numbers, but they're the wrong signs. If I take a negative 5 out instead, this becomes positive, and this 4 becomes negative. And now our parentheses match. So we're on a better track right now. The parentheses that match, those are our first factor, 3y minus 4. Our second factor is the numbers out in front, which is 2y minus 5. So this is our final answer. Hopefully that went well for you. If not, you're going to have some more practice on the next page. Okay, on this next page, we have one more that we're going to do together in terms of splitting the middle, and then we're going to mix everything together. So if we look at this first example, one of the things I told you is that we always need to start with the greatest common factor. So the last few examples we've done didn't have a greatest common factor. But here we do. What we're going to notice is that every term has an x. So we can factor that x out. When we do, we get negative 2x squared plus 21x minus 27. This looks much better than what we had before. Now, I am not a big fan of negatives, and I really don't like when the first term is negative. So what I'm also going to do is I'm going to take a negative out also from everything. So now, in front, I have negative x. This now becomes positive 2x squared minus 21x plus 27. Now, I notice if I multiply that negative x in, I'm going to end up with the same polynomial that I started with. What I want to do now is factor this part. This is where our splitting the middle comes in. So again, we're going to multiply the first number and the last number. We get 54. We are looking for two numbers that multiply to 54, but that add to negative 21. So what I want you to do right now is pause the video, come up with those two numbers, and see how far you can get. Let's see how we did. The two numbers that you should have come up with are negative 18 and negative 3. Now hopefully we remembered what to do with those numbers. The process is called split the middle because we are rewriting this middle term. So instead of negative 21x, we're going to end up with negative 18x minus 3x. Now we need to remember, or to verify, is it true that negative 18x minus 3x gives us negative 21x? Well, yes, it does. That means we're on the right track. First term stays the same, and last term stays the same. Splitting down the middle. On the left side, out of my two terms, I can take out a 2x. I'm left with x minus 9. I need to be able to take something out so that I'm left with x minus 9. If I want this first term to become an x, I need to take out a negative 3. Now, our parentheses match, which is a good sign. This becomes our first factor, the x minus 9. Our second factor is the stuff outside, so that's the 2x minus 3. Now, that's not the final answer. We have to remember we took a negative x out at the beginning, so that still belongs out in front. Now, one thing to show you, I told you at the very beginning that you can check your answers. And you can check your answers by multiplying things back out. So what I want to do real quick is multiply this back out to show you that we ended up with where we started. If I multiply these two out, you can either FOIL, which I'm not a big fan of, or use the box method. So the x minus 9 goes here, and then the 2x minus 3 goes here. If I multiply 2x and x, I get 2x squared. If I multiply 2x and 9, I get negative 18x. Negative 3 times x is negative 3x, and then I get a 27. So right now I have negative x from here. When I combine my like terms, I get 2x squared minus 21x plus 27. If I multiply the negative x in, if I distribute it in, I get negative 2x squared plus 21x squared minus 27x. And actually this should be an x cubed. Now, this is exactly what we started with. So that proves that we got the right answer. Okay, you now have some to do on your own. What I want you to do is pause the video and do these next few on your own. Make sure that you show work. Okay, let's see how we did. This first one, you should have factored out a 3. When you do, you can then factor your result to be x minus 2, x plus 2. This next example, you should end up with x minus 6, x plus 1. This last example was our split the middle example. So I hope that you started by looking for a greatest common factor. You should notice between the negative 24, 16, and 30 that they're all divisible by 2. If you took my advice, I would take out a -2 so that our first number ends up being positive. If you do, you end up with 12x squared minus 8x minus 15. Now, 3 terms. First term has a coefficient that's not 1, so then you should have multiplied your first term and your last term, and you ended up with -180. So you should be looking for 2 numbers that multiply to a -180, but add to -8. Once you found those 2 numbers and you did your split the middle, you should have ended up with a final answer of -2 multiplied by the quantity 6x plus 5 times 2x minus 3. Hopefully those went well for you. Now, if we're starting out the chapter with factoring, that must mean that factoring is important. We're going to be using factoring the whole rest of the chapter. I know this is a pretty tough start for us. If you have questions, you need to ask them tomorrow. If you want to watch the optional video, if you need extra practice, watch the optional factoring video to get some extra practice. But if you do not know how to factor, you are going to have a hard time this chapter. Please make sure when you come in tomorrow that you have work for all 3 of these problems. If you do not have work, you will not receive credit for the video.